Okay, so for those watching the lesson this evening, good evening. I'm recording this at the request of a student. And I'll be putting this in both my quick classes. So here we go. All right, so the lesson we're doing tonight is on what's called polar coordinates. The math of this isn't necessarily difficult. The last little part is a little tricky. It's just a different way of graphing. So up to this point, you've done graphing on Cartesian coordinate systems. We're going to be graphing things according to polar coordinates. With polar coordinates, and by the way, everyone should have the notes on this. I have the notes for section 10.1 and 10.3. They are available in Canvas. They're both available in module 14. They're together. Okay. I then put them as two separate attachments. So if you're looking for the notes to print for 10.3, they are directly after the notes in 10.1 in the same file I uploaded in module 14 in Canvas. So in a rectangular system, you're used to graphing things by points like X, Y, okay? But in a polar system, we graph things by what's called our theta, okay? And just like anytime you have two different ways to express the same thing, or you have like two different languages, there's often a way to convert them. And there's a way to use mathematics to go back and forth between the system, okay? Let's explore this R theta a little bit to see how this kind of plays out. And actually what I'll do to demonstrate this is I'll go through some of the examples that are in the notes here first. I think it's probably the best way to kind of illustrate this. So let's take a look. Ooh, I put the answers to no, I'm gonna block these. Hang on. There we go. I suppose you're really swabby. You probably try to see what the answers are through the paper. And let me see if I can bring this down just a little bit. If I put this close, it usually comes out pretty clear. But most of you probably have this in you probably see this in your notes already. How many people have printed out the notes for today's class? Yeah. I don't know if maybe for the notes, how many people do it on a computer instead? Like how many people work with the notes on a computer? Okay, so most people are using notes. Yes, okay. So I'm looking at see if I can get this. Jeez, can I get this to focus? All right, hopefully that's not too bad. Okay, that's pretty good, pretty clean. Okay, so now let me show you how this works with a few examples and I'll have you try this, okay? So when what I do with this here, and I'll show you how I do this on paper. So the first four, I'll show you how this works. We have the point 2 negative 11 pi over 6, okay? So usually what I do is I don't look at the radius in this. I look at the angle and I see where the angle takes me. Let's say I have an angle of negative 11 pi over 6. That's going to take me all the way around here, okay? Now, you see here, they have these little ticks. You can almost think of these like little ticks as like a number line, okay? And wherever we measure the angle from, that's where it's positive. If we go the other way, that's going to be negative. Okay, so let's take a look at 2 negative 11 over 6. Negative 11 pi over 6. I go negative 11 over 6. Okay, this is going to be my positive angle here. This is my positive number line. The other side's my negative number line. Okay, well, this is my angle I'm going to work with right here. And then for the center, I count up 1, 2. So number 13 is going to correspond with choice A. I'm going to show you a few more to get the gist of this. Take a look at 14 now, okay? Here's negative pi over 6 for the angle. How do I get to negative pi over 6? I go down this way. I go down negative pi over 6. That probably is nothing new. But because I count negative 2, this is like the positive part of the number line. Going the other way is the negative part. So I go down negative pi over 6. I don't count 1, 2. I'm going to count negative 1, negative 2 for this one. So this second value here is going to correspond to B. For 14. Let's take a look at 15 now. This is -2 pi over 6. So watch what I'm going to do here. I'm going to go up pi over 6. This is my 0 point. And because they want me to go -2, this is the positive part. I'm going to go backwards. -1, -2. So 15 is going to correspond with point C. Let's check out 2, 7 pi over 6. So I'm going to go pi, 7 pi over 6. So this is the angle of 7 pi over 6. Now, because I'm touching this part here, this would be the positive part of the number line because I've taken the angle this far. So this is the positive part. This part's considered now the negative because I've taken the angle here. So I'm touching the positive part of that number line. I'm dragging the positive part of the number line here on that angle. So if this is the positive part, the other side's the negative. What is this here? This is positive. So that's going to be point C here also for question 16. Okay. Let me show you kind of how I do these examples on a sheet of paper. So I'm going to walk you through these four kind of independent of this. Okay. So some examples here. This is going to be 13. And this angle here is going to be 2. Sorry, hold on. 2, -11, -11 pi over 6. So what I'm going to do with this, I'm going to start with like 0 and then go to the right. That's going to be like my 0-degree angle. I want to go 11 pi over 6. -11 pi over 6. Now, okay, this is my angle, -11 pi over 6, right? And when I drag this angle around, this is going to be the positive portion of it, because that's what I drag around, the positive portion. If I want the negative one, I'm going to go to the other side. So this is going to be my negative. Where does it tell me to go? It tells you to go to 2. 1, 2. So that's going to be the point I'm looking at here. So this is the point 2, -11 pi over 6. I'm going to do a couple more examples till you get the gist of this. 14. My point here is -2, pi over 6. Again, I'm going to start with my 0-degree angle here, okay? And this is going to be -pi over 6. So from here, I'm going to go down to -pi over 6. So here's -pi over 6. That's the angle. So this part is going to be my positive part of the angle. My positive part of the number line. If I go the other way, this is going to be my negative side. Where is this telling me to go? It's telling me to go to the negative part. -1, -2. And there's going to be my point. -2, pi over 6. And there's going to be my point. I'm going to show a few more so that you get the gist of this. You'll get some chance to practice this too. I'll leave these up here and I'll put a few more. Here's 15. 15 is 2, 7 pi over 6. So again, I'm going to start by drawing my 0 angle. 7 pi over 6, that's a little more than pi. So that's going to bring me like around like about like this. So I'm going to draw my angle this way. So this is what? This is my positive angle. I always drag my positive angle wherever this is. If I go the other way, this is the negative. Not a negative angle, but this is like the positive part of the number line. This is the negative part of the number line. Now 15, sorry, 15 is -2, okay? So I draw the angle 7 pi/6. And then I say, okay, which way does it want me to go? +2 or -2? If I go positive, I go this way. But since it's telling me to go negative, I'm going to count -1, -2. And there's my point -2, 7 pi/6. It's kind of like if it's positive, you stay on the line you draw. Like if this is going to be the line you draw for the angle, you stay here. If it's negative, you go the opposite direction. Just like here, when I drew this angle -pi/6. Because this is negative, I go the opposite direction and count it off. Here, I drew this angle, it's positive, so I cut my point on that line. Let's go with 16. This is going to be 2, 7 pi/6. So I'm going to draw the angle 7 pi/6. This is my positive part of the line. And because this 2 is positive, I'm going to stay on this line. 1, 2. And that's going to be my coordinate 2, 7 pi/6. Okay. So what I'm going to give you an opportunity to do now is take a look at problems 17 through 20, and then you're going to try to figure out which point these correspond with, A, B, C, or D. Okay, most of you have these in front of you. Okay, hoping these kind of stay clear-ish. Stay still. Okay, does everyone have the points like in front of them? If you don't, can you get with someone that does, please? And what I want you to figure out is, like, for example, the point 2, 5 pi/6. Does that correspond with point A, B, C, or D? The point -2, 5 pi/6, A, B, C, or D. Each of the points in 17 through 20 correspond with a letter on the graph. Can you figure out what letter corresponds with what? Okay, let's give you about 5 minutes to work on this. Okay, go on. All right, let's take a look at this. I look at the angle first. It's 5 pi over 6. That brings me here. It's 2, so I'm going to stay there. Okay. If it were negative, I go the other way. That's 2, 1, 2. So this is B. So 17 is going to be B. Now take a look. Here's 5 over 6, the negative 2. So 5 over 6, negative 2, I go the other way. And I count 2 from here. That's going to be D. 7 pi over 6, and then negative 2. So I go 7 pi over 6. Once I go 7 pi over 6, that would be 2. But because it's negative 2, I'm going to count 1, 2 this way. So this is going to be A for 19. And then 11 pi over 6, and go 11 pi over 6. This is 2, because remember, wherever I go, it's always going to be on positive. But yeah, in fact, that's 2, so that's going to be choice D. Okay. So that is how like graphing polar coordinates work. And that's one element of what you have to do. Graph the angle first and then figure out. If it's positive, then you count on the line you're on. If it's negative, you're just going to go through the origin and count to the opposite direction. Questions about that? All right. So here it says, plot each point given in polar coordinates. Okay. Let me put this here. So we get some more practice doing what I was doing earlier. So what I'm going to do with this one, I'm going to put these on a paper and I skip about 4 lines in order to show the graph. So this is going to be 21. The first point is going to be 3 pi over 2. 1, 2, 3, 4. 23. Negative 2, 0. 1, 2, 3, 4. 25. 6 pi over 6. 2, 3, 4. 27. That's going to be negative. Oops, sorry. Get up there. Negative 2. 3 pi over 4. 29. 4. Negative 2 pi over 3. And then 33. Negative 2, negative pi. So this is going to be some more practice. So I'm going to try some, and then I'm going to have you guys try some and see how you do with this. Yeah, after this, guys, one more new topic on Tuesday. After that, you do your practice final, and then the final exam. By the way, I have confirmed your final exam is Tuesday, December 13th, Tuesday, December 13th, from 7 to 8:50 p.m. And we'll do that. Yeah, we'll do that here. So, of course. Yes.
Is there gonna be like a practice test final?
Yeah, yes, I'll do a practice final. Yeah, so besides grading your test 3 this weekend, which I intend to do, I'll be also making your practice final. I'll probably be writing your final this weekend too. So, yeah, I don't want to go into like the weekend before your final, writing your final exam. I want that written ahead. So you'll probably get, I'll probably be posting the practice final exam online in Canvas once I get that done. But the first thing that I'll do will be your test 3 scores. And I will be distributing those back in class on yeah, and by the way, I know you'll see like this room is pretty packed when people come to test, but it's like a lot of students are skipping class. I know that some students are, know the trick already and, maybe just didn't place well for some reason. When I bring the test back Tuesday, like I'm, I will bring them back Tuesday, I'll probably bring them back Thursday. I am not bringing anything back, if you don't pick up your stuff. I'm not talking to you guys, because I think usually the people usually are, but if you're not picking up your stuff, I'm not bringing it to the final exams. Okay, I'm carrying in one thing on final exam week, your finals, that's it. You don't know how heavy that bag gets with all the papers I carry for all my 4 classes. Yeah, you don't pick up your stuff before the exams, you are not getting it back, alright, so. Just, I'll be providing opportunities to get that stuff, make sure to get it, please. Let's take a look at this now. All of these are going to begin with the origin and a line going to the right, okay, so. All these are gonna begin with origin, line going to the right. Because we have to have a starting point for each of the angles. All right, so all these are gonna have that. Okay, not bad. So first thing I'm gonna do is I'm gonna go to the angle. Now, what I'm gonna do, once I get to that angle, here's my angle pi over 2. I'm gonna draw a number line. Here's the positive part with my angle. Here's the negative part, all right? Now, this one's pi over 2, 3 is positive, so I'm gonna go up 1, 2, 3. There's my point right there. Let's take a look at the next one. 2, 0. Yes. Bills just scored. Ooh. 23, 7. No, I don't get that. I do get excited about math sometimes, but not quite that excited. Like I said, my wife doesn't know how much. My wife doesn't know how much you're gonna pay for the tickets to the Super Bowl either. Right now they're trying to charge like $6 grand. I'm probably gonna wait till the last day, because, the prices they are wanting to charge for these tickets is ridiculous. And they'll come down the last day if people want to sell them quick. Yeah, so we're leading by 2 touchdowns and a field goal. Nice. All right, so this tells me I don't move anywhere. Okay, so if I'm not going to move at an angle, guess what? This is my positive angle. This is my positive one. If I go the other way, that's my negative one. So there's the point, -2, 0. So I'm going to count this way, -1, -2. Boom, there's my point. Okay. Six pi over 6. So pi over 6, that's about 30 degrees. I'm going to come up here. So this is going to be my positive side. This is going to be my negative side. This is positive, so I'm going to count up 1, 2, 3, 4, 5, 6. There's my point. 6 pi over 6. I'll do one more. I'll leave you to figure out the last two. -2, 3 pi over 4. So this one I want to show you. If you go 3 pi over 4, that's about over here. So when I draw this, this is my positive part of the number line. Going the other way, that's going to be my negative part of the number line. What is this telling me? -2. So here's my angle, 3 pi over 4. Count -1, -2, and there it is. Okay, so what I want you to do is I want you to try. Question? Try 29 and 33. Try 29 and then 33. I feel like tomorrow should be Thursday. So the fact that it's like Friday, well, it's nice on Friday, I go like nowhere. Like even Wednesday they have off hours, so I'm not quite as deep coming in here on Thursday night as I usually am, because Wednesday I usually teach at Norco, but I'm done with that semester. I'm back in a couple minutes, have fun with these, and we'll check in with you.
I'm not involved in this. Yeah. No, I just always talk about being love because we pretty much submitted everything. Not final, it's just like, uh, pretty much like, a nice polished draft of everything. No. Yeah, I like. it. They're just making you do a lot of work. He expect them- He'll tell you like, oh, do this. And then he'll send you an email like Wednesday night telling you, okay, now I expect all of this to be done tomorrow. And it's like, whoa, you told us only this was needed Tuesday. Or only this was needed on Monday, so. I think it's fine, it's a great place. I'm always the stuff behind. I always finish earlier, I mean, I'm pretty much done by the other day. Don't worry about it. If I need to submit some answers, then.
Oh, I'm doing mine. That means, what's not occurring?
Also, I asked them.
Oh, that means they're not going back to the system. I want to test tomorrow. I'm really starting to start
What class?
file and I'm failing. So, yeah. Get back there.
Yeah, he's so honest. You can't like.
See, I'm not, I think we're telling me, because I need to Google if there's so many more things. Well, they're bankrupt. Really? Yeah. Yeah. So many, everywhere. Monster sued them. Monster Energy sued them twice. One for false advertising and two for like health reasons. Very nice. So she's in the. Anything to do with the wrong server, the company with its EPA. No.
All right, let's see, look. -2 pi over 3. This is the positive angle. This is the negative. So that's +4, we'll count off 1, 2, 3, 4. And there's our point. -2 pi. This is gonna be interesting. Go around this way, there's -pi. That's my positive angle, this is negative. But this is -2, we're counting off 1, 2. And there's my point. Now, they don't have to look, I mean, yeah, these are like approximate drawings, you know? How many people got at least one of these correct? Okay, good. So most people have the hang of this. Excellent. All right, so now what we're gonna do next is we're gonna take a look as a mathematical conversion. How do we go from rectangular to polar and polar to rectangular? Okay. And then we're gonna put down a bunch of points on the next page of notes here too. Okay. So here we're gonna go from polar to rectangular. Okay. So a few things here will be helpful. Let's see if I can get this to focus. You know, because I didn't sleep much last night, I forgot my document camera. I hate when I forget my document camera. Let's see here. Jesus Christ, can I get?
Oh, there.
There we go, okay. All right, so what we're gonna do, what you need to know, if you're given the point X, say R theta. X is gonna be equal to R times cosine theta. Y is gonna equal R sine theta. And here are gonna be my points. So we're gonna approach this in a very systematic way. Here's gonna be problem 43. This is gonna be the point, hold on. 3 pi over 2. 45. 1, 2, yeah. -2, 0. 47. Six. 5 pi over 6. 51 and 57. 51 is gonna be -5. -pi over 6. And the last one is just gonna be numbers. It's gonna be 6.3 and then 3.8. So, and for this last one, make sure your calculator is in reading mode. Okay, you wanna make sure for the last one, the calculator is in reading mode, all right? Because when you put in like, when you put like the sine and cosine in, and you want the sine of 3.8, it's gotta recognize the other radians, otherwise it's not gonna give you the answer. Not the correct one at least. So let's see how we convert this point that's in polar to rectangular. So look at the x coordinate, that's gonna be equal to 3, the r value, times the cosine of pi over 2. And then y is gonna equal to 3 times the sine of pi over 2. So we're doing this in a very systematic way. So you kind of see, you know, how the procedure of this all works. Cosine of pi over 2, that's 0, so that's gonna be 3 times 0. So that'll be 0. Sine of pi over 2, that's equal to 1, so that's gonna equal 3. So the 0.3 radical 2 in rectangular form is gonna be the 0.03. Let's take a look at a few more examples before I have you guys try a few. 0.2, 0. So x is gonna equal -2 times the cosine of 0. Y will equal -2 times the sine of 0, not sine of theta, sine of 0. Cosine of 0, that's equal to 1. That's an equal -2. The sine of 0, That's equal to 0, so that's gonna equal 0. So this point here is gonna be -2, 0. It's exactly the same as it is in polar, actually. Which doesn't really happen often, but it does happen from time to time. 6 and then 5 pi over 6. Okay. X equals 6 times the cosine of 5 pi over 6. Y equals 6 times the sine of 5 pi over 6. And then what do I get here? Cosine of pi over 6, that's in the second quadrant, that's going to be negative. That's like 30 degrees off the x-axis, so that's going to be radical 3 over 2. So this is going to be 6 times radical 3 over 2, which is going to give me 6 radical 3 over 2, or is this going to be equal to 3 radical 3? So that, oh, and this is going to be negative, by the way. So this will be equal to -3 radical 3. Well, let's see. Sine of 5 pi over 6, sine of the second quadrant is positive. That's 30 degrees off the x-axis. That's going to be 1/2. So it's going to be 6 times 1/2. That's going to equal 3. So my point in rectangular form is going to be radical -3 radical 3, 3. This is the point in polar. This is the point in rectangular. Questions on those 3 problems there? Okay, then let's go ahead and let's have you guys try 51 and 57. That's the point -5, and then -pi over 6. And then that is going to be the radius, and that's going to be the angle in radians. So that's a little bigger than pi, because pi is like 3.14, this is 3.8. That's just a little bigger than pi. You get a chance to compare with your neighbor, see what they got. We'll go over these in a minute or two. Okay, take a look at this. X is gonna equal -5 times the cosine of -π/6. Y will equal -5 times the sine of -π/6. Well, the cosine of -π/6, that's the fourth quadrant, that's gonna be positive. And that's gonna be radical 3/2. So this will be -5 times radical 3/2. And that's just gonna be -5 radical 3/2. So that's gonna be the x coordinate. And the y coordinate, this in the fourth quadrant sine's negative, and that's gonna be -1/2. So it's gonna be -5 times -1/2. Well, these are both negative, so 5 times 1/2 is just gonna be equal to +5/2. And that's gonna be 51. This first one, x is gonna equal to 6.3 times the cosine of 3.8, that's in radians. Y is equal to 6.3 times the sine of 3.8. Now, this is gonna take us in the third quadrant because it's just a little bigger than 3.14. So these are both gonna be negative. So when this is all multiplied together, x works out to be about -4.98. Y works out to be -3.85. So the point in rectangular form is going to be -4.98. And then here's going to be -3.85. Any question? Oops, sorry. Just realized you couldn't quite see all that. Any questions on either of those solutions there? Yes.
Did you just put it in the calculator and you go to negative?
Yeah. Yeah, because if you have it in radian, make sure your calculator's in radian mode. Because 3.14 would be like high radians. Okay, and if you go to 3.8, that's just like a little more than 3.14, which puts it in the third quadrant, which makes the sine and cosine both negative. So that's just a straight up calculation problem. Okay. God, the way you guys are dressed, you think it was like cold or something. You know, we call this kind of weather in New York in December. Nice day. Okay, we're gonna take now, we're gonna convert points that are rectangular, we're gonna convert them into polar now. All right. Now, there are a few things you're gonna need to know for this one. R, that's gonna equal the square root of x squared plus y squared. Theta is gonna equal to the inverse tangent of y over x. Okay. Yeah, think of it this way. Usually the weather in Buffalo is or even New York, wherever, at this time of year, you know what the weather's like in Buffalo? If you're lucky, it's in the 40s for a high. And it snows usually. And you don't see the sun for months. Sometimes you don't see the sun, or maybe once a month you see it. Okay.
You lived in a desert?
No, I taught in the desert. but while I live in California, I taught in Desert Hot Springs. And there, I'll write the problems down, and all of a sudden, I start seeing a handful of students, I would put in the category of hoodlums, wearing Detroit Red Wings hats. So I said, So I asked one of the brainchilds, hey, do you think that the Red Wings are gonna win the Super Bowl? I don't know, maybe. Of course, in hockey, we play for the Stanley Cup. Me being an avid hockey fan, I know this, and I figure his stuff is gang related. So I share my information with the vice principal, and she thinks, no, I'm being silly. And I said, we live in a place called Desert Hot Springs. As just to say we live in a desert and it's hot doesn't say enough. But they have to add the name hot. Do you really think the students give a shit about an ice hockey team? The only ice they ever saw was in the freezer. Sure enough, they investigated, and then by the next day, all sports attire was banned on campus except for the high school sports attire. They checked with the gang units, sure enough. I mean, I work at a juvenile hall, I work with, kind of stuff. But what do I know? I'm just a simple person. Yep, that's just me. Okay. So, yeah, so no, I'm a little with sarcasm. All right, so this time now, we're gonna use these formulas to get the R for here and the theta for here. Okay, and we're just gonna follow along in quick succession, okay? So this is gonna be R is equal to -1 squared plus 0 squared. That's gonna give me the square root of 1, which is equal to 1. So that's gonna be my radius part. Then theta, that's gonna equal the inverse tangent of, it's gonna be y over x, that's gonna be 0 over -1. We're just gonna give you the inverse tangent of 0. Now here's the tricky part, okay? There are two places where the tangent is 0. 0 degrees and 180 degrees, 0 and pi, okay? But if you take a look at this here, -1, 0, that is, if we take a look at -1, 0 is plotted, here's where -1, 0 is plotted. It's not plotted at 0 degrees, it's plotted like at pi. So, we have to choose between 0 or pi. Based on where this is plotted, we're gonna choose pi for our answer here. So sometimes you gotta look at the original point, plotted in polar, and make sense about which trig solution works. We'll see another example or two of this, okay? Here's the point 1, -1. How do I find R? That's gonna be equal to 1 squared plus -1 squared, which is gonna equal 1 plus 1, which will be just the square root of 2. So my R is just gonna be the square root of 2. Theta is gonna equal the inverse tangent of -1 over 1, which will give me just the inverse tangent of -1. Now, where's tangent -1? Two places. In the third quadrant, like at 135 degrees, and in the fourth quadrant at 305 degrees. 315, not 305, 315. Which means it's either gonna be at 3 pi over 4. Well, now I could put this as 7 pi over 4, or I could put it as like -pi over 4. I looked at the solution, they have this as -pi over 4. I don't care if you put 7 pi over 4. But I'm gonna put it as -pi over 4. Because if I look here, where's the point 1, -1? 1, -1, that's over here. That's the point 1, -1 is, which makes more sense to be at -pi over 4, like 7 pi over 4. That doesn't be 3 pi over 4. Although if we were to choose 3 pi over 4, we'd be looking for the point to be here. So again, that's where we're looking at the original point in reference to RLB graphs in a Cartesian coordinate system, helps us to decide which of these two values to choose. Rose? Huh? Okay, so if you find the inverse, so it's going to give you. Okay, so you see how I'm finding this to be pi over 4? It's gonna give you the decimal equivalent of it, okay? I don't know how much sense that's gonna make. I'm not looking for decimal equivalents. I'm looking for like pi in this, okay? So on a problem like 67, sure, use the calculator. On this, you need to know your trig identities, okay? Unless you're giving me like negative pi over 4, anything else you give me other than that is just an approximation. It's not exact, okay? All right, let's try 65. R, that's gonna equal 5 squared plus 5 radical 3 squared. So R is gonna equal 25 plus 75. So I'm gonna need the radius of 10 for this one. Now I'm doing these quick, but I know that these are basic calculations that you guys should be able to do. This is gonna be equal to the inverse tangent. This is gonna be 5 radical 3 over 5, which should give the inverse tangent of radical 3. Now again, there are two places where, two angles where you get the tangent of an angle equal to radical 3 at 60 degrees and at 240 degrees, okay? So it's either gonna be pi over 3 or it's gonna be 4 pi over 3. Here's where I look at the point. So here's like the point 5 radical 3. It's in the first quadrant. So I'm gonna choose an angle in the first quadrant, which is gonna be pi over 3. In the interest of time, I want to kind of get to the next two sections here. And what kind of time we got? Now we're fine, okay. Because I want to, this one will be just, I'll show the work on this quickly. This will be equal to 1.3 squared plus negative 2.1 squared. When I calculate that, that's going to work out to be 6.1, which rounds to about 2.47. And then for the inverse tan of negative 2.1 divided by 1.3 for theta. There we go. Yes, thank you for letting me know. That's going to work out to be negative 1.02. So that's going to give me a point of 2.47 and then negative 1.02. All right, now, last couple of things we're gonna do, don't deal with points anymore. We're gonna be taking a look at equations that are written either in rectangular form and then converting them to polar form, or equations written in polar form and writing them in rectangular. And some of these require some resourcefulness. Long story short, I don't think I'm gonna put questions like this in your final, but you are gonna see this in your homework, so I want you to have some exposure to them. 71. The original, okay, what properties are we gonna use for this? We know that R is equal to the square root of x squared plus y squared. We can also say that R squared is equal to x squared plus y squared. These are properties. X is equal to R cosine theta, and then y is equal to R sine theta. I'm just writing these out because these are properties we're gonna utilize. Here's the equation I'm given in 71. This is 2x squared plus 2y squared. So I'm gonna bring this up a little bit. Stay. Equals 3. So what I do is I'm gonna factor 2 out of this. That's gonna be 2 times x squared plus y squared equals 3. Well, I know x squared plus y squared is equal to r squared, so I can write this as 2 times r squared equals 3. If I divide both sides by 2, I get r squared is equal to 3 over 2. And then I take away the square root of r squared and the other side, I'm getting r is going to equal to the square root of 3 divided by the square root of 2. And if I want to rationalize the denominator, that's going to equal radical 6 over 2. So my final answer to this is r is equal to radical 6 over 2, right here. So this stuff, like what I'm doing here, a little out there. And, you know, I understand it and everything, but it's a little out there. Let me do 73 next. Actually, you can work to prepare for calculus because it requires a certain amount of resourcefulness. X squared equals 4y. One thing I'm gonna do with this first, I'm gonna go ahead and move the 4y over. I'm gonna subtract 4y. Make this x squared minus 4y equals 0. Now I know x squared is equal to like r squared. So what I'm trying to do here, I'm gonna replace x with r times cosine theta squared. So I replace x with r cosine theta minus 4 times r sine theta. That's equals 0. I'm going to distribute this now. So it's going to be r squared cosine squared theta minus 4 r sine theta equals 0. Done. So these are the kind of manipulations they're looking for you to do. So you have an equation that's written totally rectangular form with x's and y's, and now we want to just replace everything with r's and thetas. And notice we're giving the one side. Let's take a look at 75. Here we have 2x(y) equals 1. Any idea what I can replace x with? And then y I'll replace with r sine theta. This one is devious. What I'm gonna do is I'm gonna take the r's out, but I'm gonna bring the 2 back in. This is an r, this is an r, so this is gonna be r squared. Now, I'm gonna bring the 2 and make this 2 sine theta cosine theta equals 1. Why? Because this is an identity. This is r squared. 2 sine theta cosine theta is the same as sine 2 theta. And there you go. That's just a simplified version of that. How long has it been since you've seen that? I think it was pretty hot outside the last time you saw that. So, am I going to ask a question like this about this on the funnel? Probably. Okay. Let's see. 79. We have, yeah, this is a little tricky one. We have r equals, oh no, this one, okay, yes, 79 is actually when we start going from rectangular to, we start going from polar to rectangular. This is what I want to say. And this one we start going from polar to rectangular. So here we're given r is equal to cosine theta. And now they want us to go from polar to rectangular. Now, what am I going to do with this one? I can't do much with cosine theta. I need an r here. So I'm going to just multiply both sides by r to get r squared is equal to r cosine theta. You know what, actually, guys, can I, make this a little simpler? I'm gonna subtract cosine theta from both sides. No, let me do this first. Actually, my step was right. Now, let me do this. Let me subtract r cosine theta. This is gonna give me r squared minus r cosine theta equals 0. Well, what's r squared equal to? That's equal to x squared plus y squared minus what's r cosine theta equal to? X equals 0. Done. Last one we'll do, 81. I'm doing this one because it's in your homework. You have r squared equals cosine theta. Again, I need an r with this. I'm gonna make this r to the third now, equals r cosine theta. So basically, I'm just multiplying both sides by r when I'm doing this. I'm gonna go ahead and write this as r squared to the 3/2 equals, what's r cosine theta? It's equal to x. Now, what's r squared equal to? It's equal to x squared plus y squared to the 3/2 equals x. And finally, if I subtract x from both sides, I'm gonna get x squared plus y squared to the 3/2 minus x is equal to 0. Last two questions, I don't know, to me, just they only give a couple examples, and if they really want students to master it, they should provide help. But I don't make up the homework problems. That is done by the department. Otherwise, I just don't bother. I want to teach them, I want to teach them. Otherwise, they give you a lot of examples. It's not so much. Okay, let me go and stop the recording of this.